Hi, this is Mrs. Pullen. I'm going over the January 2018 Regents, example number 34. A student is chosen at random from the student body at a given high school. The probability the student selects math as their favorite subject is 1/4. The probability that the student chosen is a junior is 1/16 out of 459. If the probability that a student selected is a junior, or that the student chooses math as a favorite subject is 47 over 108, so what does that mean? So let's say that's really saying junior or math is 47 out of 108. What is the probability that the student selected is a junior whose favorite subject is math? Okay, so in order to get that information, I'm really looking for the probability of both events happening. And we can't just multiply probability of m times the probability of j together because we don't know if those two events are independent. We're not told that in the problem, so we can't do that. So it's really a two-step process. And the first step we're going to do is we're going to use this piece of information. So if you recall, the general addition rule is the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So we know in this, we're going to just put the notation here representing math and junior to make it our lives a little easier. And again, this is what we're looking for. So we know this is 47 over 108. The probability you're going to select a junior is 1/16 out of 459. The probability the person likes math is 1/4. And again, this is what we're solving for. So you could use a calculator to add the 1/16 over 459 plus 1/4. And when you do that, you get 923 out of 1836. So now you subtract the 923, 1836 from the 47, 108, and you get negative 31 over 459 is equal to negative x, and divide both sides by a -1, and you get the probability of both events happening, junior and liking math. That should be an M, and this should be an M, is equal to 31 over 459. The next part of the problem says, are the events that a student is a junior and the student's favorite subject is math independent from one another? And you could do either method that we've done before, but since we just found in part A the intersection of two events, I'm going to use this method in order to show independence. So if the occurrence of both events is equal to the probability of the first times the probability of the second, then A and B are independent. It just saves some time in this case using this method based on the information given. So we know this is 31 over 459. What is the probability? I'm saying A is junior, so the probability of being a junior is 1/16 over 459 times the probability of liking math, 1/4. And so when I enter this in the calculator, this is approximately 0.068. And this is approximately 0.063. And although they're close, I would say that because they're not close enough, that they are not independent. So since, and you have to make the statement, the probability of math and junior does not equal to the probability of math times the probability of junior, the events are not independent.